Exponential functions are used in applications involving growth or decline, and we're going to explain them next. Welcome to Math Bytes. I'm Allison, and today we're talking about exponential functions. So let's start with a definition. F of x is equal to b to the power of x, where b is greater than 0, b is not equal to 1, and x is a real number. Now, that condition that b must be greater than 0 is to make sure that f has values that are real numbers. If b were less than 0, then f would be complex for certain values of x. So let's take a look at this. We have the function f of x is equal to 2 to the power of x. So now the variable is the exponent. So let's evaluate this function when x is equal to 4 and negative 3. All right, so f of 4 is equal to 2 to the power of 4. Just like any function, you just plug in the value wherever you see an x. And 2 to the power of 4 is 16. F of negative 3 is equal to 2 to the power of negative 3, which is 1 over 2 to the power of 3, which is 1/8. Let's look at the properties of our exponential function. F is a one-to-one function. Its domain is the set of real numbers. Its range is the set of positive real numbers. F is a smooth, continuous curve with y-intercept 0, 1, and the graph passes through the point 1b. If b is greater than 1, f is an increasing function, meaning as x approaches infinity, f approaches infinity. If b is greater than 0 but less than 1, then f is a decreasing function, meaning as x approaches negative infinity, f approaches infinity. Let's take a look at a graph. Here's a graph of the function f of x equals b to the power of x for b greater than 1. Now you'll notice the negative x-axis is an asymptote. That means as x approaches negative infinity, the graph of the function will get closer and closer and closer to the x-axis, but it will never reach it. Now, here's a graph of f of x equals b to the power of x for b greater than 0 but less than 1. Now, the positive x-axis is an asymptote. So as x approaches infinity, the graph will get closer and closer and closer to that positive x-axis, but it will never reach it. Just one more thing. Exponential functions have y-intercept 0, 1. So why is that? Let's take a look. F of x is equal to b to the power of x. Now the y-intercept is where x is equal to 0. So let's evaluate f of 0. F of 0 is equal to b to the power of 0, which is equal to 1. So it doesn't matter what the base is. These functions have y-intercept 0, 1 for this reason. Bacterial growth and decay, compound interest, population growth and decline. All of these are applications of exponential functions. They are well worth understanding. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com. And we'll see you next time.